Okay, since we gotta start somewhere, let's start by moving our platform. We have this leaves bush here, and that's basically our player, because we're gonna be able to move this, let's say, character to the left and to the right, because the apple is gonna move towards the ground and we gotta catch it. We can't let the apple fall to the ground. This is the basic rule of the game. So I'm just gonna explain a little bit about moving something around and how we do it, so we can get this right in our head and can apply this to other stuff. So I'm just gonna open up my drawing app here, and this is our basic structure. As you can see, this is my bush here, and there's a Y component that points upwards, and there's an X component that points to the right. Of course, we gotta receive input from somewhere. So we have basically two options. We can receive input from the mouse. So moving the mouse to the left means we're gonna move the bush to the left, and so on. We can also receive input from keyboards. So we can maybe use A and D, or maybe left and right key. So for simplicity, let's say that this is our system here. So how do we move something in programming or in game development? How do we move something? To move something, we basically need to add a contribution to that object's position. So let's say we have a ball here. This ball is placed at let's say a position 0, 0. So if I want to move it to the right, and basically moving to the right has, of course, a vector that points to the right, and that vector is 1, 0. That's 1 for X and 0 for Y. So if I want to move this ball to the right, that means I have to get the position of the ball and increase it by a vector that points to the right. So basically by doing, let's say, b.pos, it's going to receive itself plus c, which is a contribution. So in the other frame, in the next frame, the ball is going to be in this position, which is now 1, 0, because I summed the current position to the contribution, and that gives us 1 and 0. In case I do this again, and I sum the current position to the contribution, my ball is going to be in the vector 2, 1, because we sum component by component, and this is how we got our answer, okay? And this is basically how our platform is going to work. If you notice here, I already pointed out a vector that's called vector3.write, and this is basically short for writing 1, 0, 0. So 1 for X, 0 for Y, and 0 for Z, which means that this vector is going to point directly to the right. So if I get the platform, if I get its position, which is currently here, and if I move it by this vector, multiply it by the amount of movement I want to add, I can end up here or here, because it depends on my input. Basically, if I got a positive input, which means that I want to move to the right, I'm gonna have a vector that points this way. If I got an input that goes to the left, that means I'm gonna multiply this vector by -1, and that in short terms mean that I'm gonna inverse its direction, so it's gonna end up pointing this way. So depending on the input, the direction of my movement is going to change. And I pointed out here that moving the mouse to the left is going to cause a -1. Moving to the right is going to cause a 1. So this is for the direction of the movement. The same happens for the A and D keyboards. Alright, so now how do we code this? First of all, I'm going to create a folder, and I'm going to call it scripts. This is where we're going to place every script that we possibly write. And I'm going to create a new one. I'm going to call it platform. Double click to open it. While it's opening, I'm just going to show you something very quick. As I said to you, we need to have access to the position. We need both access to writing to the position and to reading from the position, because we need to use the position to add a contribution and then place the position again as the current position of our platform. So if you click on the leaves brush here, I move it slightly to the right. So I'm just going to reset its position. As you can see, I'm changing the position under the transform component. So by doing this via script, we need to access the transform component and then access the position. This is how we do pretty much anything in scripting in terms of changing some object's behavior. We have to access a component, and from that we can change a variable that's stored inside of this component. In this case, we want to access the transform component and change the position that is, of course, an attribute of the transform component. So to do this programmatically, let's say we want to do this in the update function, which means that we are doing this at every frame. To get access to the transform component, we need to do get component, and then in between minus and plus signs, we place the component that we actually want to have access to, which is transform with an uppercase T, and put your parentheses here. This function has no attributes, no parameters, just a semicolon here, meaning that this is a comment. So this comment or statement is going to return us an instance of the component transform. So we gotta store it somewhere, right? So I'm just gonna store it on a transform local variable. I'm gonna call it T. So basically T has a reference to that component, has a reference to the transform component where this script is going to be attached to. So now if I do, for instance, t.position receives t.position plus some contribution, let's say vector3.write, whenever I place this script onto any object, it's going to start moving to the right immediately. Okay, so let's try this out. If I add this script to our platform and if I hit play, it's gone, and you can see the position increasing by 1 at every frame. But how do we get this this input? We're gonna get it through what's called an axis. So from the name, maybe you can derive what it does. An axis is something that has a value that varies in one direction. So for instance, the axis for a mouse input is going to vary between -1 and 1 depending on the direction of the mouse movement. And of course, I mean the mouse X component. The mouse Y component works the same way, but we're talking about the X component because it's a logical thing. We want to move the mouse to the left or to the right to move the platform to that same direction. If you want to have access to the axis that Unity already has, you can click on Edit, Project Settings, and Input. So you can expand the axis here, and here are the axes that you already have. So there's a mouse X1 here. That's basically going to give you this behavior that I pointed out here. It's going to give you -1 when it's moving to the left. It's going to give you 1 when it's moving to the right. It's going to give you 0 when it's not moving on the x-axis. And it's going to give you something in between if you're moving at a slower speed. So let's try this out. Let's try to get this value. So of course it returns a float because it's something that varies between -1 and 1. I'm going to store it in a float variable. So I'm going to call it mouse X movement. This is going to be the result of that axis, whatever value that axis is being right now. So to get access to that, we need to go to the class input, which is of course the class that handles any sorts of inputs, that being keyboard, mouse, anything like that. And then we type get access, which is the function that will return as the value for a axis that we define. In our case, we want to type mouse X here, because as you can see, let's go back to Unity, they have a name, and this is the name that we need to pass in to retrieve the value. So any of these axes, they have a specific name, and you need to pass that as a string to get its value. So in this case, what we need to do is just to multiply the right direction by this mouse X movement, and then we get a working behavior. If you go back to Unity and if you hit play, you can see that by moving the mouse to the left and to the right, I get the corresponding effect on the platform, okay? Of course, we can add a velocity so we can control it better. So I'm going to expose a public float, which is going to be the velocity. And I can just, of course, multiply this value by the velocity. So a smaller value for the velocity is going to give me a smaller contribution to the position, which is going to make my bush move slower, okay? Going back to Unity, if I select the leaves bush, which is where the script is attached to, I have this velocity variable here, and setting it to maybe 0.1 gives me the motion that I want. Let's think of something here. This function update runs at every frame. Let's say that you run this game in a faster computer. What that implies? It implies that the update function is going to be called more times per second because that computer has more power and therefore is going to bring the FPS to a higher value. If you run it in a slower computer, the update function is going to be called less times, which means that if I call this line more times per second, it means that I'm going to move my object at a higher speed. If I call this line less times per second, it means that I'm going to move my object at a slower speed. And this is a problem because, especially if you have games that are multiplayer, you don't want to have a player that runs faster than the other just because that player is running the game in a much better computer, right? So you have a special variable that scales the time based on the velocity of that computer, and that variable can be accessed in time.DataTime. So this is the variable. It basically tells you how many seconds it took the computer to render the last frame. And what this is going to do the following. So let's say that I got an FPS, which means frame per second, and I'm going to put an age here, which means that's for a better computer. And I'm also going to multiply that by the time it took it to render the last frame. So I'm going to say delta time sub age. This has to be equal to FPS dot L, which is sub L, which is basically the FPS for a slower computer, times delta time sub L, which is the delta time for a slower computer. And why is that true? Because when the FPS increases, the delta time decreases. Because if your FPS is higher, it means that every frame takes less time to compute. So this variable is going to drop down. In this case, as the FPS goes down, the time it takes to render a single frame goes up. So this equation holds and makes such a fact that depending on the computer, a player cannot run faster than the other. This is a very powerful effect that sometimes is not explained well, and you got that thinking, oh, I don't understand this, I'm just going to type in because someone told me. So this is what's actually going on. And just before we get done with this lecture, of course, since time.DeltaTime is a very small value, we now have to increase the velocity to a large value in order to get a good movement. Okay, so I'm going to increase it by 20. 20 seems to be too much. Maybe 5. And 5 seems to be a good value. And what you can also notice is that I can move my platform off screen, but you can see it has a limit. When I get here, it means that's the limit. And by the transform, you can see that position is 3.4 roughly. So what I'm going to do is I'm going to clamp the position in the x-axis between a limit that I define. So to correct that, what I'm going to do is I'm going to expose a variable here, which is going to be the limit on x. So first of all, we need to get access to the axis that we want to clamp. In this case is the x-axis. So I'm just gonna put the x-axis on a variable that's a float. I'm gonna call it current x, and this is equal to t.position.x, basically the x value of this transform currently. And to clamp this value, I basically want to say that this position needs to be between minus limit on x and plus limit on x. It has to be clamped in between those values. Why? Because I know that my character, my platform, is aligned in the x-axis. It means that it starts out at 0, so it needs to be in between those values. So to clamp this current x, I basically have to call a function that's going to make this adjustment. So I can say current x is equal to mathf, which is the class for mathematical functions, dot clamp, and this is going to clamp a value in between min and max. The value that I want to clamp is current x. The minimum value is minus limit on x, and the maximum value is plus limit on x. But now I just have the value clamped. I need to reattach it to my position. And to do that, I need to assign a new vector to the position. So t.position is equal to a new vector. The x has been changed, so I need to pass in the new x, which is current x. The y doesn't change, right? So I'm just going to pass in t.position.y, which is the current value for y. Since it doesn't change, I can just pass the current value. The same happens for z. Okay, so this is going to clamp the platform so it doesn't go off screen, given that we provided the correct value for limit on x. So going back to Unity, now we have this limit on x, and you can see that it goes off screen when it gets higher than 3.4, let's say. So I'm going to put the limit on x being 3.4. I'm just going to zero out this x-axis. When I hit play, you can see that it doesn't go off screen. Once it gets smaller than minus 3.4, it gets the value minus 3.4, and once it tries to get higher than 3.4, it receives the value 3.4. So this is what clamping does. Alright, so this is it for this video. In the next one, we're going to move our platform using keyboard inputs.